Okay, good. So we have, I'm on page 6. Okay, the next, we do not cover 3.7, so we can directly move on to 3.8. And I promise to stick with simple situations. So in 3.8, we're going to talk about something called implicit differentiation. Another application. What is this implicit? What about direct? What's the difference between these two? What is direct differentiation? And what is implicit? There must be a difference. This is direct. I have the function, I'm differentiating. So as an example right here, if I have a function f of x equals 3x squared plus 4x, I'm using direct differentiation to find f prime. Can anyone give us this? Very simple.
6x plus 4.
That's it. But what about this? What is that implicit differentiation? If I have, for example, y cubed plus 2y plus x squared equals 4xy, and I'm asked to find dy over dx, in other words, y prime, which we do not like as notation in this case, I can no longer use direct differentiation. Not possible, because I do not have y. I cannot solve this equation for y. Here I was given y equals 3x squared plus 4x, and you actually gave me dy over dx as being 6x plus 4. There is no y on this side. There is only one y. That's why I'm using direct differentiation. Here I have no choice but use implicit differentiation because I'm not given y, and I cannot solve this for y. Not possible. A computer will do it, but we cannot. So how will I find dy over dx? Okay. Well, remember when we solve an equation like the square root of x plus 1 equals 2, or e to the x equals 4, or x to the third equals 8. In all these situations, we are applying a procedure, right? We are applying a procedure or an operator to both sides. What operator do I apply here to solve this equation? What do I have to do or apply to both sides? The same thing to solve for x. Exactly. I think somebody wanted to say that. Of course. What procedure I apply here to solve?
Natural log.
Exactly. What procedure I apply here to both sides at the same time?
Cube root.
Exactly. Awesome. I'm so proud of you for following and answering questions. Thank you so much. Well, I have to do the same thing here. But none of these, but this. I have to differentiate implicitly because I do not have the direct function. I have to implicitly differentiate. So here I squared, here I apply natural log. All these are operators. The operators of squaring, the operator of natural log, the operator of cube root. This is another operator. And I have to apply it to both sides at the same time. Okay. Keeping in mind that when I'm asked to find dy over dx, this specifically means y is a function Of what? Of
X.
Exactly. So careful. Let's see how we differentiate. That's the only thing we need in section 3.8. So piece by piece, slowly but surely. A function to the third power differentiated. What do we get? When we differentiate,
3y squared.
yes, times, we can never forget that times the inner function prime. So this is not a variable. Y is a function of x. So when I differentiate y to the third, I bring 3 in front. I subtract 1 from the power. But since this is not plain x, it's a function of x, I have to multiply by y prime. But we don't want that notation because I'll show you why we don't want that. Is it wrong if I replace this by y prime? No. You can. It's fine. But don't. And I'll explain in a minute why. Good. Now we reach the second term. Can anyone differentiate this for us?
It will be just 2
Careful. This is a function that
times dy over dx.
Brilliant. Now we are here.
2x.
That's it. Awesome. Perfect. Now we are here. Now this is tricky. Why? Because it's a product. If I don't apply the product rule, I will never get the correct answer. So here's the first function. Here's the second function. Let's try. The first function prime. Very good. Times y plus the first function times the second function prime.
Is it going to be just dy over dx?
That's it. At this, calculus ends here. Now it's just algebra. I have to solve for this variable. I notice that this variable is present in this term, they are on the left-hand side, but also present in this term, which is on the right, so it has to be moved to the left. So 3y squared plus 2 minus 4x. I already factored out dy over dx. 3y squared, positive 2. This term gets moved and its sign gets changed. And I factor out dy over dx. 4y is on the right-hand side, but there is a little term that does not have the variable, so it has to move to the other side. Finally, we are solving for this. This is just algebra. Can anyone tell us what is at the top and what is at the bottom?
4y minus 2x on the top, and then 3y squared plus 2, and then my.
Now, if you say, wait a minute, yeah, you found an expression for the derivative of y, but it still has y in it. Yep, that's fine. I don't have y. But I found a rate of change of y, an expression for it, given this equation. Okay, let's look at an example. This one was just made up by me. So let's look at page 359. 359. And now it's time for you to choose. Differentiate implicitly to find dy over dx, then find the slope of the curve at the given point. Anything you like from 15 to 33. Anything.
26.
26. Let's take a look. Where is 26? I see it. Perfect. Awesome. Oh, 26 on 359. Xy minus x plus 2y equals 3, and the point is -5 2/3. Perfect. So they want to find us to find dy over dx and then find the slope given the point. Perfect. Good. Can I solve this equation for y? In this case, I can. Right? It's a linear equation in y. I could, but let's not do that. We want to use implicit differentiation. This is a simpler situation than this one. Here I cannot solve for y. There is no way. Here I can, but let's say we cannot and proceed accordingly. So we want to, so remember, every time I'm asked to find dy over dx, this automatically tells me y is a function of x. Do not forget that, please. So y prime will be dy over dx. Not 1. It's not a it's not a variable. It's a function. Okay, good. We're ready. So we're differentiating x times y.
Will it be y?
Is it?
Go ahead.
Be y plus x dx times dx over dy.
Yes. Very good. Yep.
-1.
Yes.
2 times dy over dx equal 3.
Careful.
I mean, equal 0.
Excellent. That's it. This is our variable. This is what we are solving for. At this moment, this is just algebra, nothing else. So we factor out dy over dx. I have x plus 2. I have to write x plus 2 times dy over dx. I have to move -1 to the other side, and I have to move y to the other side. And now I have dy over dx. And after that, I will plug in x equals -5 and y equals 2/3 and find the answer. Anyone?
It's 1 negative y, and then on the bottom it's x plus 2, but instead of y, we're going to put 2/3. And then instead of x, we're going to plug in -5.
So -5 plus 2 is -3. So 1 minus 2/3 is 1/3 over -3, -1 over 9. And that's it. So now you understand this may look not useful, but once I have x and y, I already have an answer. I have the slope of the tangent line to that point, the given point. Any questions on this? Any questions? Can I choose one now?
Yes.
Okay, let me see. I want to choose a demand and supply. Okay, so what about 34? They're all the same. But of course, different situations. X times P over X plus P equals 2. And they give us the hint, clear the fraction first. In other words, multiply both sides by, or cross multiply in this case. Okay? We do not, there is no need to talk about logarithmic differentiation. Logarithmic differentiation, we apply the log first and then differentiate. So there is no need for that. So I'm happy with what we're doing here, just the implicit differentiation. So first we cross multiply. So we have, this is over 1. This product equals this product. So xp equals 2x plus 2p. And now let's see carefully what they're asking us to determine. So we have to go back for a second. It says for each demand equation, differentiate implicitly to find dx over dp over dx. What does that mean? We're asked to find dp over dx. What does this mean automatically? That
P is a function of x.
exactly. Please always remember that. Thank you so much. P is a function of x. Good. So we're ready. Okay, let's start. Anyone?
Is that going to be instead of x is going to be 1, so dp over dx?
We careful, the product rule. The first function prime is 1 times the second function. Now plus the first function times the second prime. Careful, this is a product. Function 1, function 2.
Oh, then it's going to be dp over dx.
Good, awesome. Now on this side.
It's 2
Good, plus.
plus 2 times dp over dx.
That's it. So we are after this piece. This term has to be moved to this side, and p has to be moved to this side. So when I move it, the 2 becomes negative. So x minus 2 dp over dx equals 2 minus p. Final step, dp over dx equals
2 minus p over x negative 2.
That's it. So we determine the rate of change. Again, this was not a complicated situation we could have solved for p.